Hello student, this is Dr. Faizan Mirza. I'm using dcpip to measure the rate of respiration using yeast suspension here, and dcpip is a redox dye. So how rate of respiration can be measured using dcpip? What I'm doing here, I'll take yeast suspension and I'll add dcpip to it, or methylene blue either can be used. Both of them are redox dye, and what I'm doing here, both are redox dye and they both are hydrogen acceptor, and they are blue in color, and when they accept hydrogen they turn colorless. So blue color actually is oxidized dye and colorless is the reduced dye. Now what I'll do, I'll take a test tube. In the test tube I have yeast suspension, and to this yeast suspension, for example at 10 ml of yeast suspension I have in a test tube, and to this test tube I'll be adding 2 ml of glucose. For example 5% glucose is added to it. I know the glucose will be used by yeast and it will start to respire. I'll spread a thin layer of oil at the top, and this oil will prevent oxygen from entering into the yeast, so this will not allow oxygen to enter, so yeast will keep on respiring here, and all the gases which are being released here, they won't be allowed to escape either. So we can expect that since there is no exchange of gases occurring, whatever is happening here will stay within this condition, because the oil will not allow mixture. It will be a barrier for between these two interface. Now I'll keep this in a water bath, for example at 20 degrees Celsius. I have placed this in at a certain temperature. I'll add 1 ml of methylene blue or dcpip into this, and the contents of the test tube will start to appear blue because dcpip or methylene blue has been added. Now once this is added, I know that this is oxidized state. What I'll do next, I'll note down the time taken for the blue color to get discharged, because as the blue color gets discharged, it means that the dye is undergoing reduction. It's gaining hydrogens which are being released by the respiration of yeast as it uses glucose. The experiment can then be repeated at different temperatures, for example 10, 30, 40, 50, 60 and so on and so forth, with fresh samples every time and using the same quantities. It can be repeated 5 times for each temperature, and the mean can be calculated there. A colorimeter can be used to for a more precise reading of the color intensity, which can be taken out from the digital reading rather than just judging the color endpoint by the eye. So you can use the colorimeter values as endpoints to note down the maximum you can say change of color change, you can say the maximum color change that is seen there. The calculated rate, the rate is always calculated by 1 upon time. So this is how this experiment works. That's it from my side. Thank you so much.